All right, everyone, get ready because on today's deep dive, we're diving into the world of LLMs. You know, those large language models that seem to be everywhere these days. And one thing about these LLMs, it's like
They're kind of like that friend who shows up to a potluck empty-handed, expecting you to have cooked for an army.
that is scary accurate. They just want more and more data.
An insatiable appetite for data, that's for sure.
Mm.
And listeners, you've probably heard by now that these LLMs need mountains of data to learn. But what happens when we start running low on that high-quality stuff? Well, that's where today's deep dive comes in. We're looking at this research paper by Rishabh Agarwal.
That's right. The paper's called Improving LLM Reasoning Using Self-Generated Data, RL and Verifiers.
Get you right.
Well, the title's a mouthful, I'll give you that. But the idea itself is fascinating, that these models could basically create their own study guides.
Yeah, it's a pretty radical concept when you think about it, and it gets at a real challenge we're facing in AI. It's one thing to have an LLM that can write a decent email, but to get them to really think critically, to problem solve.
Now you're talking about a whole different ballgame.
Exactly. And that next level requires a ridiculous amount of data.
Mountains of it. Which is expensive, it takes forever to process. It's like trying to build a skyscraper out of toothpicks.
Okay, that's a good analogy. You're trying to build this massive, complex thing, but the resources are limited. So imagine if instead of searching for more toothpicks, we could somehow teach the model to make its own building blocks.
Whoa, okay, now hold on a second. My inner skeptic is kicking in here. Isn't there a risk that these models will just get stuck in some kind of echo chamber, repeating the same mistakes and biases over and over again?
You bring up a really good point. It's a huge concern. There's actually a term for that: model collapse.
Model collapse.
Yeah, think of it like that game telephone. You whisper a phrase around, and by the time it gets back to you...
Oh, it's completely different. Always good for a laugh.
Right, but not so funny when we're talking about sophisticated AI, right?
Yeah, that's a recipe for disaster. So what are we doing to prevent that?
Don't worry, researchers aren't just letting these models run wild. They've come up with something called ReSTEM. It's a method for safely training LLMs on this self-generated data.
Okay, ReSTEM. So break it down for me. How does this thing actually work?
Let's see. Imagine you're learning a new skill. Like, say you're learning to play the piano.
Okay, I like where you're going with this.
So, you practice, you hit some wrong notes, you learn from those mistakes, and over time, you get better.
Right? Practice makes perfect, or at least less terrible.
Right, exactly. So, ReSTEM works in a similar way with two key steps. There's the E step and the M step.
E step, M step.
Yeah.
Sounds like a new dance move. All right, walk me through it.
So in the E step, the model is basically generating its own practice exercises, its own training examples. And this is the cool part. There's a feedback mechanism that filters out all the duds, keeping only the successful attempts.
So it's like a really, really strict piano teacher. Only the flawless pieces make the cut.
Exactly. And then the model gets to study those successes.
So what happens to all those filtered out attempts? Do they just get tossed aside like a musician's crumpled up sheet music?
That's where it gets really interesting. Those mistakes, those filtered out examples, they actually play a key role in training something called verifiers.
Verifiers. Is that like the AI equivalent of a quality control team?
I got it. Think of it like this. Imagine you're trying to teach an AI to write really compelling marketing copy, right?
Okay, I'm with you.
A verifier would be like having a seasoned marketing expert, someone who can look at a ton of different drafts, some good, some not so good.
Yeah.
And they develop this almost sixth sense for what really resonates with people.
So they're not just saying yes or no, they're giving feedback like,
Right.
This copy doesn't highlight the product benefits, or this one's great, love the emotional language.
Exactly. And here's the thing. These verifiers, they learn just as much, if not more, from the incorrect solutions. It's like when you're first learning a new language and you make a mistake and someone corrects you.
Oh, tell me about it. I once told a French baker I wanted to eat his hat instead of his bread.
And I bet you never mixed up those words again. Those corrections, they stick with us.
Big time. Okay, so how do these verifiers actually work with the self-learning models? How do we bring these two pieces together?
Great question. The paper talks about a method called V-star, which combines the power of ReSTEM with these expert verifiers. So now, instead of practicing in isolation, the model is getting real-time feedback, which makes the learning process so much more efficient.
It's like having that marketing guru right there with you, giving you instant feedback on your copy as you write it.
Precisely. And the results really speak for themselves. V-star consistently outperforms models trained with just ReSTEM alone. And here's another cool thing. It can actually handle increasing amounts of computing power, which is a big deal because in AI, usually more power equals better results.
So bigger is better.
It often is. But V-Star, while very promising, it's not the only approach out there. Think back to that marketing copy example for a moment. Instead of just one expert, what if you had a whole team of marketers, each with their own area of expertise, all giving feedback?
Now you're talking. My own team of AI marketers. Where do I sign up? But seriously, what would that look like?
That's kind of the idea behind an approach called majority voting. Instead of relying on a single verifier, you generate multiple solutions and then go with the most popular one.
So like crowdsourcing the best solution?
Exactly.
Yeah.
It's a bit simpler than V-Star, but it can be shockingly effective in practice.
Interesting. Okay, let's go back to these verifiers for a second. You mentioned they can actually explain why a solution is right or wrong. That seems like a whole other level of analysis. How does that work?
That's where we get into the next generation of verifiers, something called generative verifiers.
Generative verifiers.
These are like the Sherlock Holmes of AI. Not only can they tell you the answer, but they lay out the entire chain of reasoning, step by step.
Okay, now that's just cool. So instead of a simple yes or no, we get a detailed explanation.
You got it. Like, this solution is incorrect because it failed to factor in these specific variables.
Wow, that's amazing. So it's not just about being right or wrong, it's about understanding, well, why behind it. That makes a lot of sense. So any other benefits to these generative verifiers? It's like having a whole panel of experts, each weighing in with their own perspective. You know, I do love hearing different viewpoints. It's always good to get a more well-rounded view. But okay, I have to ask, are there any other cool advantages these generative verifiers bring to the table?
Oh, absolutely. One of the most interesting things is their ability to use something called chain of thought reasoning. It's like, instead of just spitting out an answer, the AI actually shows its work, explaining each step in its thought process.
So it's not just giving you the answer, it's walking you through how it got there.
Right. It breaks down the problem into smaller, more digestible steps.
That's cool. So it's kind of like it's easier to trust the answer if you can see the logic behind it, right?
Exactly. And here's another cool thing. With these generative verifiers, you don't need separate models for generating solutions and then verifying them. They can do both, making the learning process much smoother.
Okay, this is blowing my mind a little bit. So we've got these self-learning models, these crazy smart verifiers, the ability to really break down complex reasoning. What's next? What else is there?
Well, we've been talking a lot about these big, powerful models, but what if we could get incredible results with something a bit smaller, something more streamlined?
Now you're speaking my language. Who needs a supercomputer when you can get it done with something leaner and more efficient? So, tell me more about this.
So that's where the idea of compute-match sampling comes in. It's all about choosing the right tool for the task at hand.
Right, you wouldn't use a chainsaw to cut a tomato.
Exactly. Sometimes you just need something smaller, more focused, especially if you don't have unlimited resources to throw around.
Makes sense. So it's about working smarter, not harder.
Right.
Making the most of what we've got.
Absolutely.
Yeah.
And that brings us to one more technique that I want to touch on. It's called reinforced in-context learning. Remember how we talked about how LLMs can learn from just a handful of examples?
Oh, yeah. Like that friend who can whip up a gourmet meal after just one YouTube video.
Right. Well, reinforced in-context learning, this takes it a step further. It's like, not only can they replicate the recipe, but they're also adding their own little twist each time. You know, they're constantly learning and refining, getting better with each try.
Like an AI chef that just keeps getting better and better with every meal. I like it.
It's a pretty delicious way to think about it.
So we've covered some pretty mind-blowing stuff today. Self-generating data, these super smart verifiers, and even the power of keeping things small and efficient. It feels like we're on the edge of a major AI revolution.
We are. And the research really opens up so many possibilities. We're talking LLMs that could help doctors with diagnoses, help engineers design eco-friendly cities, or even create truly personalized learning experiences for every student.
It's like we're giving these AI tools the ability to really think for themselves. And not just think, but solve problems and come up with new ideas.
And to make it even better, these advancements are making this technology more accessible and efficient. It's a pretty amazing time to be following AI.
That's for sure. Well, that's about all the time we have for today's deep dive into the fascinating world of LLMs. A big thank you to our expert for being an expert. And to all our listeners, as always, we want to hear from you. Head over to our social media and let us know what really stood out to you today. Until next time, keep exploring and we'll catch you on the next deep dive.